All right. Hello, everyone. I am not there, but I would like to make sure this is recording. Nice. Yeah, we're going to jump a little bit in the notes. I was looking through knowing that I'm not going to be there. I think that some of the stuff from 1.4, 1.5, I think we got to do that more in person. What we can do without me being there, I think, is a little bit more on the graph, despite your feelings about graphing points and stuff like that. I think doing this early in the week will be helpful. So try to turn to 1.6. It's going to be a little odd since we're not going, 1, 2, 3, 4, 5, 6. We're going to do 1, 2, 3, 6. So what's going to happen, I think, in our schedule here is we're really just going to shift this up, like we're here on this Monday, right? And our skill assessment is going to be Friday here. I think we just take this lesson, move it up here, and then everything gets shifted down one. I think that will be the best case scenario based off of me not being there and you probably not having a math teacher to show you how to do these things. So, let me show you distance of segments. We saw that segments are, let's scroll down. Oh, don't get too dizzy there. And I should have these things graded by Tuesday, I would hope, so that you can check how you did. The skill assessments, obviously. We saw that segments are 2 points, made of 2 points, and they stop. And so that's kind of this whole section and what it's going to be. And our mission in this week's time is to find the measure of how far is it from here to here, right? And so there's lots of ways you can do that. We were going to start off pretty simple, but we're just going to go straight to the graph and start graphing some points and find the distance of those things. And then we'll find out more stuff in person, a little more stuff without a graph. But we're going to start with the graph today. So let's look at this weird amusement park problem. Geez. Spring break and your friends are excited to go to the Wild Wonders amusement park. Ooh. Assume that you always take the shortest route, most direct path between attractions. Yeah, you don't want to waste time. You got to take the shortest path. Each unit represents a meter. Okay, so everything's in meters. Great. You enter the park and realize you are starving. Ooh, pretty hungry. I know some people that get hungry, especially in that period 5, 7. Oh my gosh. Conveniently, there's a food truck stationed at 00. Okay, so food truck 00. Hopefully you remember what 00 is. How far is the food truck from the entrance? Okay, so I don't think, I guess I'm just going to kind of give it to you now. How far is the food truck from the entrance? Where's the entrance? Let's see. Oh, it's right here. Oh my gosh. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh. 8 meters. Yeah. It's not really traveling on a diagonal. So we have pretty easy counting abilities. From the food truck. This is the food truck, I think, right? Who walks farther? Oh, sorry. From the food truck, you want to go to the milk jug. Okay. You want to go to the milk jug. Oh, wow. That is pretty far. There it is. There to there. Your friend walks straight to the right. All right. Your friend will be in pink. Straight to the right and then down, and you walk diagonally. Who walks farther? How do you know? How much farther? Okay, so, I guess we're not really supposed to be able to count this. Your friend looks like they're going to walk 8 and then down 1, 2, 3, 4. Oh my gosh, bad counting. So that'd be a total of pink friend goes 12, 4 plus 8 meters. It's kind of hard for you to measure yours unless you have an equation that would help you. But I think the shortest path would usually be you, right? Like you are walking directly towards it. They have to walk extra far. So let's see. We can find the distance, any 2 points, using these coordinate points, 2 sets, using the formula. Let's see. We have the distance formula is the square root of x, well, you can go y, I guess. Y minus y squared plus x minus x squared. Now, some people will be like, well, you gotta do 1 minus 2 and 1 minus 2. Now, other people write this slightly different, but I think doing 1 minus 2 is probably the most sensical. Nice. And so if we use our points in our problem, you are starting at 0, 0. You end up at, let's see this point, 8, comma, negative 4. Yeah, let's see what we got. So remember, this is x, this is y. This is x, this is y. We can make this the first one, this is the second one. So I'm going to go square root of the y's, 0 minus negative 4 squared plus 0 minus 8 squared. So this is just a positive 4. 4 squared is 16. This is negative 8 squared. Negative 8 times negative 8 is positive 64. Still inside the square root. Add those together. 70, 80. I think 80. And then from here, you're probably just going to have to type in the calculator. Let's see. Got a calculator. Square root of 80. For now, I guess that's going to be satisfactory. Square root of 80 is 8.944 meters. Yeah, we definitely walked a shorter distance than our friend. Beat ya. So this is interesting, and we're going to see this come up again later. The basis of the formula comes from the Pythagorean theorem, or vice versa. The Pythagorean theorem is a squared plus b squared equals c squared. Now, I said that in a different order than this did, but in our purposes, let's reorder it to c squared equals a plus b squared kind of thing. A squared plus b squared equals c squared revolves around having a right triangle, which we always have in a graph, right? Because we have going up and down and left and right. Now, what is our distance of our horizontal and our vertical is basically what it's looking for. Or horizontal, well, in this one is 3, and our vertical is 4. But maybe we don't have that. Maybe we have just these coordinate points, which is why we're finding the difference of them going in for A and B to just find that distance 3 and 4, right? And so there are the coordinate points, right? 5 and 1 and 1 and negative 2, right? Because where are those coming from? We have, let's see, this coordinate point would be right 1, up 5. That's where these 1 and 5 pieces are coming from. Use a different color. And then we have this one here. That's going to be negative 2 and positive 1. That's why you're getting negative 2 and positive 1 there. And so we're finding the difference so that we can find that 3 and 4 pieces, right? And basically you can see that this squared is coming from this, what can turn into that square root like we had in the distance formula up here. So it's these two formulas is what I'm trying to tell you. These two formulas, try that again. These two formulas are the same. This one uses coordinate points just to help you find the vertical and horizontal distances. That way you can find the thing you're actually looking for, which is the diagonals. So that was a long way of saying, you could use both equations. You could use this one or you could use this one, whatever's easier for you or whatever's easier for the situation you are presented with. So Some people will probably just prefer the Pythagorean theorem just because it's easier to just count. 1, 2, 3, 4. Yay, I'm done. Got 4. And 1, 2, 3. I got 3. Great. A squared. These are your A and B. Your hypotenuse, your diagonal is always C. That's another good point. Diagonal is always C. It doesn't matter which of these are your A and B because you're going to add them anyway. And adding is commutative, which means it doesn't matter what order. Cool. All right, that was a lot of fancy language. Let's do some more problems. Honestly, you should probably just pause the video and just try these and then see if we get the same thing. Honestly, I'm just gonna use the Pythagorean theorem here. Or, well, here's the other thing. I know the difference between -3 and 7 is going to be my horizontal distance. So the difference of those numbers is 10. So this is me 10. Even if I can't see that, that's pretty hard to see. But I know that's the difference. And then the difference of the 5 and the -1 should be a total of 6. So that's my A and B squared. I'm going to put those into my formula. I'll try to stay color coordinated for you. 6 squared plus 10 squared equals C squared. Okay, so we get, what do we got? 36 plus 100 equals C squared. Square root, oh, sorry, I'm jumping the gun. 136, C squared. So square root of 136 is, let's type it in the calculator. Square root of 136. Oh my gosh. 11.662. I like to go 3 decimals. I think AP exams look like that in case you're into that kind of thing. Maybe ACTs like to go 3 decimals. So I'm going to run 3 decimals on you. And then round it. Okay, try these other two. You can go a little faster if you subtract them, or you can just go the long way. I'll do the long way, and then I'll do a shorter way the second time. So this is the long way. Here are my x's, and here are my y's. So let's go 7 minus 2 squared. This is the distance formula, by the way. What's this other one? Plus, we got 3 minus 7 squared. And then, let's see, this is 5. 5 squared is 25. This is -4. -4 squared, 16, because you have a negative, positive. And then these together is 41, I think. Hopefully I get these right. This is about 6.403. Yeah, it doesn't have any meters or anything like that. Last one, I'm going to go a little faster. The difference between our x's is 2. Oh, sorry. Oh, yeah, that's right. 2. That'll be 2 squared. And the difference between our y's is, well, it's -6 and 1. So I know it's going to be 7, like a distance of 7 if I'm thinking about a number line. This is how I'm thinking in my noggin, whatever, right? There's a distance of 6 and 1, so it's a total of 7. That's how I'm thinking about it in my head, in case you wanted to peek there. All right, and then, right, this is C squared. So let's go 4. Let's go 49 equals C squared. This is going to be 53. And take the square root to get rid of the square. 53 squared. Still not a square number. 7.280 distance. Right, remember, these numbers are the length of a line that connects 2 points on a coordinate grid. So let's see, this would be 7, -6, down here, something like that, 5, 1, be like that. This is 7.28-ish, or the square root of 53, right? That's what you're finding. This is square root 53. So we're going to find other ways to get distances that are a little less technical and more whole number based, but on a coordinate grid, if we want the precise length, that's what we would do. Pythagorean theorem is the a squared plus b squared equals c squared, or the distance formula. All right, let's see what this says. What is the horizontal distance between the 2 points? Oh my gosh, I feel like we just did this. All right, the horizontal distance is our x's together. So the distance between -5 and 3 is 8. What is the vertical? Actually, what you're doing by doing this is doing the absolute value of these, which whatever this answer is, the difference, the distance is the difference between these 2 points. So whatever you get as a result here will be the answer, but absolute value means it turns it positive. So 8 is your answer, right? Because it would be -8, but absolute value makes it positive. All right, less talking here. Distance between 2 and 9, that's the vertical. That would be 11, I think. That's good. What is the actual shortest distance between the 2 points? Oh my gosh, it's Pythagorean theorem. Okay, 8 squared plus 11 squared equals our shortest distance. The hypotenuse, right? We took the shortest distance from the food truck to the entrance, or I forget where it was. Some part of the amusement park. 121 plus 64 equals c squared. Okay, let's add these up. I'm not feeling like adding in my head anymore. C squared equals 185. Square root of that. Oh my gosh, another not square. All right, I get C equals about 13.601. Great, something to that effect. Okay, pretty good. Find the 3 different locations for point C such that, we didn't talk about this, this thing. All right, we're going to talk about that in 1.5 especially. This symbol looks like an equal sign, but it's not. It's something called congruent. That's a fancy way of using an equal sign in geometry. When we want to talk about a picture that is equal to another picture, we use the word congruent, and this is the symbol spelled like this. So we need AB to be congruent to AC, but there's no C. I think we're supposed to draw a new point C. Find 3 different locations for the new point C such that these are going to be equal. Well, let's see. We know the distance from here to here would be 2 and 3. Well, if we want something that's the same, which way should we go? We could maybe go the other direction, maybe like up 2 and right 3. That would be an idea. But, I mean, maybe consider doing the same thing in every direction to make even like a box or, rectangle of sorts, right? I think these would all be 2, 3, which shouldn't that get you the same distance? They have the same vertical and horizontal distance as that pink line, connecting to there and there to there. So I think these would be the locations. Does it want the points? I don't know. You can give it the points, I guess. What is that? 5, 1. This is 5, 5. This is -1, 5. Oh, yeah, that's right. And that's yep, that's it. That's the only one. That's the 3 locations. Last thing, and then I'm just gonna have you practice the rest of the class if you have time, and I think we'll just pick it up then tomorrow, Tuesday. Graphed in the standard y-x coordinate plane below is a right triangle with the vertices 0, 0, -40, 0, and 0, 30. What is the length in coordinate units of the hypotenuse? What is the length in coordinate units of the hypotenuse of the triangle? What is the length in coordinate units? What is this talking about? All right, maybe pause the video and then see if you can do it. I'm going to think about this for a minute. What is the length in Coordinate units. Well, I think I'm just going to use Pythagorean theorem and find the hypotenuse and see what happens. We know this is 30. This is 40. So let's go. Oh, I already know the answer, maybe. I don't know what it means by coordinate units, but I think I could take a good guess. Maybe it's just pertaining to use the coordinates to use it, to find it or something. This is 900. This is 1600. And because I'm really, really smart, I already know the answer. But I'm going to write all this stuff anyway. It's 50. And so that would be your hypotenuse. That's the length of the hypotenuse. It doesn't really give coordinate. I don't know what that means. So, yeah, if you got 50, nice job. That was not a bad ACT question. It's just kind of worded funny. All right, try this practice. I'll have the answers up, and you can check them. There's only like 3 problems, geez. A little more than that, but try those. If you'd like to try looking at the other practices, that's the last note that would be on the skill assessment. If you want to go back to the 1.4 practice 2, maybe try doing some of this. See if you can do it on your own. That'd be a good segue to start off class on Tuesday. If you knew some of that, if you didn't, that's not the end of the world. But I would definitely do the practice now. And then if you want to get a jump start on this practice, that'd be cool too. All right. Hope the day goes well. I will see you Tuesday. Peace.